don't you give it the first stab? Just a very short.
Quick definition, man-manipulated DNA designed for short-term profits.
You think that's a good definition?
Well, please expand on it.
No, I'm just that's my, I just give a script. So.
No, in a popular sense, that does, yeah. What genetic engineering is, we tend to use the word genetic engineering in the US and Europe and elsewhere. They use genetic modification. They functionally mean the same thing. It's about moving genetic materials, nucleic acids. It can either be DNA or sometimes it's RNA, and it's moving it between organisms in ways that don't happen naturally. And the real problem with genetic engineering is the companies try to say it's more precise because you're only moving one gene, right? A trait, say you want herbicide tolerance, you're only taking that gene and moving it into the plant. And they say when you do conventional breeding, if you're trying to get disease tolerance into a tomato and you cross it with the wild tomato, well, you're bringing in thousands and thousands of genes and you only want one or two. And it turns out the thing that's fundamentally different about genetic engineering is it's an artificial technology and they have no control over where they're inserting this genetic material into the genome. And that turns out to be crucial because genes occur at specific locations on chromosomes. Those are over evolutionary time. They tend to be conserved, so in many different plants, for example, the genes that will be expressed in the seeds often occur in specific locations, right? And so when you're doing any form of breeding, even if you're doing wide crosses with two different things, there's a sort of evolutionary way that organisms know how to do that. With genetic engineering, you're really inserting things and you have no control over where you're inserting it, and it's the disruption that can be caused. That's what the main concern that the critics have pointed out. It's not just that what you're putting in should be looked at for whether it's dangerous or not, the gene itself, but it's what it's doing to the rest of the genome because of this problem of insertion. So it isn't more accurate. It's only more precise in that you're only moving one or two genes rather than thousands, but you're doing it in an unnatural way. Think of conventional breeding like shuffling different decks of cards. You still are dealing with all the same cards, whereas genetic engineering would be like taking a 2 of clubs and putting a part of a 7 of spades on it, right? So that's stuff that doesn't happen naturally. And it turns out that since genomes have sort of evolved, they can detect when this foreign material comes in and they react in certain ways, and that's why many of these engineered plants have all sorts of